So what you're doing is you're trying to get logs with the same basis, set them equal to each other. Once we have the logs isolated, we can then set their arguments equal to each other and solve for the variable.
Is this like
There's two different ways to do this. One is if you have a log on one side of your equal side. So there's a log and the other side has a number. So we'll do that first. What you want to do is condense. So if you have multiple logs on one side, use our rules for condensing and get it down to one log on one side of the equal sign. Once you have that, you convert to exponential form. And then from there, you're going to just have an equation that you're going to be able to solve. Okay, the last thing, and this is going to be true on both of the types of equations that we solve, we have to check for
I'm not checking my work yet. No.
Extraneous.
Anything you tell us, anything where we can't check, I never do it.
That's fine. Is the log or the argument to a log. So in the parentheses, the argument to a log cannot be negative. So you just have to check that the answers you got, when they plug back in, that they don't make that argument negative. Okay? So you have to check for those, because if you put an answer that isn't true, you're going to get it wrong. Okay? Okay. So that's with logs on one side. If you have logs on both sides, then what we want to do is condense. Okay. So condense one log on each side, apply the property of equality. So set the arguments equal to each other. Solve. And then we'll say no extraneous solutions. Because there are not more than one log. So we already have the log by itself on one side. So solve, get the log by itself, divide both sides by 4. So then we've got our log base 7 of negative x equals 2.
Condense.
How? Multiply. Okay? So then you need to foil.
Are we getting a trinomial?
Yeah.
Oh, no. You actually, bro.
Foil. It's coming back. X squared minus 3x minus 10 equals 3. So 2 to the third equals x squared minus 3x minus 10. How do we solve a quadratic? We set it equal to 0 and factor. So 2 to the third is 8. So we're going to subtract 8 from both sides. We have to set it equal to 0. So we get x squared minus 3x minus 18 equals 0. Then we solve with our x method. So after we've done this, we go back up, see, look at our arguments.
Can we just take the 50-50 chance?
You could do that if you want. 6 is going to be fine. But if we plug in negative 3 to either of these, it's going to give us a negative argument. So we have to reject negative 3. First step to isolate the log would be to do what? Divide by 2. So then we get natural log of 5x equals 3. Now we're going to rewrite this in exponential form. What is my base of the natural log? E. We're going to leave e in, we're not going to multiply out e as 2.718, whatever. Just leave it as e. To the third equals 5x.
Is that it?
Well, one more step to get x by itself.
Oh, yeah.
Divide by 5. So e to the third over 5 equals x. We'll skip. Let's skip this. That one's super easy. Let's do 6 real fast because it's super easy. Notice that the bases of the logs are the same. When you have one log on each side and their bases are the same, you just set the arguments equal to each other. You get rid of that log and you say 5x minus 6 equals negative 2x plus 8. And then you just have a regular linear equation to solve.
That's really nice.
Okay? So we'll add 6, We get 5x equals negative 2x plus 14. And then add 2x.
It's just 2.
So we get, yeah, so if I go over here a little bit. 7x equals 14. Divide both sides by 7. X equals 2. Okay. Let's do 7. Okay. Notice we've got 2 logs on the left. We have to get it to 1 log before we can start to solve. So we're going to do what with these 2 arguments?
You just
Multiply them, right? We're going to do log base 9 of x times x plus 23, which is going to be x squared plus 23x because you distribute it.
After we're done with that, can we just take the top parts because the base are the same?
Yep. After that, you have to condense first. But then after that, now we've got a log with a base of 9 on the left, a log with a base of 9 on the right. So now we can just take their arguments, x squared plus 23x equals 50. So set the arguments equal to each other and then solve for x. Okay, set it equal to 0 and solve.
It's going to be negative 52.
So move this over here. We get x squared plus 23x minus 50 equals 0. Set up our x. Negative 50 goes on top, 23 goes on the bottom. So what, 25, negative 2. X plus 25, x minus 2. So x could equal negative 25, x could equal positive 2. If we check back to our original, will negative 25 work? No, we have to reject that.
Wait, so anytime it's negative, can you just like cross that one out?
Well, you have to always check because remember the one we did where it was like negative x, and then when you plug the negative back in, it made it positive. So just check. Like you just have to kind of look.
And you,
Okay.
So you just don't, you're
That's my log.
Okay.
Doing number 9.
Doing number 9.
What we're gonna do, since we have the same for each one,
Yep.
we can pretty much just bring down
nope.
our x.
So condense the log, multiply. Once you have it down to 1 log, exponential form. Now we have a quadratic. How do we solve a quadratic?
God.
Set it equal to 0 and solve. Okay? So negative 6, positive 1. What would it be? 3, negative 2. So x plus 3,
Nobody can get these as fast.
x minus 2. So x could equal negative 3, or x could equal positive 2.
It's going to be 2.
It's going to be 2 because we can see this one is a problem if we plug it back in there. So we reject that, and only 2 is our answer. So, log is the inverse of an exponential. We use it to isolate a variable when it is in the exponent. Okay, so we need to remember compound interest, which is A equals P times 1 plus R over N to the NT. So you will be given this. You don't have to memorize it. Like, all right, so if we do this one, how long does it take to double $1,000 in an account with an interest rate of 6.35% compounded monthly? You always want to pay attention to this because this is going to tell you which interest form, like which formula you're going to use. Because it is compounded monthly rather than continuously, we're going to use regular compound interest formula. A equals P times 1 plus r over n to the nt. So then let's go back to our words, and we're going to figure out what each of these things are. So if you're going to double $1,000, that means you want to end up with $2,000. So A is 2,000. Our principal amount is 1,000. Our rate is 6.35, but remember we have to change that to a decimal. So we move the decimal point 2 places to the left and get 0.0635. And then compounded monthly, that means 12 times a year, so our N is 12. So when we plug all this in, we get that A, which is 2,000, equals P, 1,000, times 1 plus our rate, 0.0635 over N to the NT. So you can see that we have T up here in an exponent position. So in order to solve for T, we're going to have to use a log. So we're going to go back and start doing our computation. 2,000 is fine, equals 1,000 times 1 plus 0.0635 divided by 12 is 0.00529. So 1 plus that would be 1.00529 to the 12t. Now we have to work on getting that 12t by itself. First thing we'll do is divide both sides by 1,000, because that gets us one step closer. 2,000 divided by 1,000 is 2, equals 1.00529 to the 12t. So we need to get this t out of the exponent position and into a solving position. The way we would do that is how we get any exponent out of the exponent position, which is by turning it into a log, because the answer to a log is always the exponent. So we can get the exponent down next to the equal sign rather than up where we can't get to it. So when we rewrite this as a log, this is our base, the base of our power. So we'll take log base 1.00529 of 2 equals our exponent. And then the last step will be to divide both sides by 12 to get t. This you can put all into your calculator. So that's a calculator problem. It will solve that for you. To find this log base button, there's the regular log, right? The common log that has the implied base of 10. But to find log, you go into the math menu and then you scroll down. I think it's A, and it says log base. And then you push enter, and it will give you the option to put in whatever base you want of your log so that you can then solve this problem. So when we get this, we get that t equals about 10.94. Well, I guess if we rounded, it would be about 95 years. Okay, a couple other examples. Go through as many as you want until you feel like you understand how to do this. All right, this one says $30,000 to accumulate to $110,000 in a trust that earns 10% annually and is compounded semi-annually. So again, because this is not continuous, we're still going to use our regular compound interest formula. All right, our A value is this, what it's going to get to. P value is 30,000. Our rate will be 10%, which we changed to a decimal, which is 0.1. And semi-annually means twice a year. So our N equals 2. Let's plug all that in. So we get 110,000 equals 30,000 times 1 plus 0.1 over 2 to the 2t. If I do this in here first, bring everything else down, we get 0.1 divided by 2 is 0.05, so 1.05 to the 2t. Then start getting that t by itself so we can get to our log. Divide both sides by 30,000. This gives us a fraction, so we get about 3.666. It goes on forever. 7 equals 1.05 to the 2t. t. From here, we can write this as a log. The base of our log will be 1.05, so we'll have log base 1.05 of 3.6667 equals our exponent to t. Last step to get t by itself, we'll divide both sides by 2, and then we can plug this into our calculator. So t equals 13.32 years. So that's how long it would take for the money that you deposited to grow to 110,000. All right, let's look at this one. Certificate of deposit earns 4.25% compounded continuously. So notice the difference in this wording. We can't ascribe an N value to continuously compounded interest. This is where we're going to use our special formula that contains an E to talk about something that is continuously compounding. So here we have our P value. We have our rate. When we move the decimal, we get 0.0425 continuously, and then time is in years. So because of that continuously compounded interest, we're going to use our continuously compounded interest rate formula. A equals P times E to the RT. We are looking for A. We know that P, our initial deposit, is 5,000 times E to the rate, 0.0425, times our time, which is t. Order of operations comes into play here. First, do this math. So 500 E 0.0425 times 3 is 0.1275. My goodness. 75. Then you need to take E to that power. So your E button in your calculator is right above the natural log and right below the log. It's in blue. So you'll hit second natural log, E to the 0.1275, which is 1.1359. And then multiply 500 times that, and we get the final value of this after 3 years would be about $567.99. So remember, we always go out 2 places with money. That is all. All right.